Hello and welcome. We are looking at properties of parallel lines. Alright, so what I have here are two lines L and M. Now these ones aren't necessarily parallel. In fact, it's better to assume that they're not because we want to say that these relationships still occur no matter what we're looking at as far as lines. I have two lines here. At some point they must intersect if they're not parallel. That's the arrow indication that they go on forever. And there's this other line going through. I'm making it red here to make it very unique. This is line T. This line T is my transversal, or transversal line. You can just call it a transversal. It's a line that intersects two coplanar lines at two distinct points. So by coplanar, as you're looking at your computer screen or your phone or whatever, obviously they're on that plane. Basically, they can't be skew. This intersects through those two lines, okay, and at two distinct points. By that I mean, you want to avoid looking at a situation that looks, say, like this, and then the transversal goes through one distinct point, right? Those are two coplanar lines and everything else. So you want to make sure it goes through those. That way, you can start talking about all these different angle relationships. Because so far, all we've looked at are, as far as special angle pair relationships, are adjacent angles and vertical angles. Let me ignore this top section completely right here. Let's just look at this bottom, this cross section between lines T and M. Well, adjacent angles would be, for instance, angles E and G. Okay, or angles E and F, or angles F and H, or angles G and H. Same with vertical angles. I could just use lines F, or angles F and G. Angle F and angle G. And that's a specific relationship there for vertical angles, such as, and E and H are also vertical angles here. Anyway, the point is, I only needed two lines for it, not two lines and then transversal. Here, these other ones require that. So here you have two lines. They don't have to be parallel for these relationships to happen. Here's a new relationship called corresponding angles. By corresponding, it means, I mean, it's going to be easier to tell when they're parallel, but essentially facing the same direction. So angle F and angle B, as you can tell, they correspondingly go like up and to the right in this case. Those are corresponding angles there. So angle B and angle F. That's just one example. I could use another example. I won't write it down, but I'll say angle C and angle G. Those are corresponding angles. They're on the same side of the transversal. One's on the inside and between the lines, the other is outside of the lines there, and they go in the same general direction. That's how corresponding angles work, so you could list other pairs of them there as well. Alternate interior angles, interesting term, but it makes very much sense if you think about it. Alternate means on opposite sides of the transversal. Interior means inside your two lines for which you're referring. So a pair of alternate interior angles in this case would be angles E and D. Angles E and D are alternate interior angles. What's the other set of alternate interior angles here? Angles F and C. They are on opposite sides of the transversal, and they are on the insides of the lines, interior. And they're angles, so they're alternate interior angles. Alternate exterior angles would be the opposite, well, not the opposite. Their angles are still on opposite sides of the transversal. Say B. Who's the alternate exterior angle with B? Well, on the opposite side and on the outside, but not this one here. They need to be on the opposite, way on this opposite side right there, G. Angles B and G are alternate exterior angles. So alternate interior on the inside of, on opposite sides of the transversal, exterior on opposite sides of, and on the outside of your lines there. H and A, angles H and A are also alternate exterior angles. Same side interior angles sounds pretty appropriate. On the same side of the transversal, such as here and here, and on the inside of your two lines to which you're referring, such as F and D. So angle F and angle D, and obviously then that also means that angles E and C are also alternate interior, same side interior angles. And same side exterior angles, well, we're just with one more set of things, such as A and G. Those are same side, I keep saying alternate, same side exterior angles. Okay, let's now start talking about this with reference to parallel lines. Now, what if those lines instead aren't distorted and perhaps intersecting? What if we knew for sure that they were parallel? Well, now these angle relationships have something very specific about them where we can talk about the measures of the angles. They might be congruent. They might be supplementary. In some cases, they might be complementary, but not in these specific cases. So we're going to look at how, how vertical angles are congruent, B and C, for instance. They're congruent. Well, there are some other things about alternate interior angles and same-side exterior angles and corresponding angles, such as corresponding angles. Here's a postulate, and here's something that I can't really prove beyond having you say, well, I totally see what you're talking about. If a transversal intersects with two parallel lines, by the way, these arrows here are marking parallel, then their corresponding angles are congruent. So by corresponding angles, what did we talk about before? F and B? F and B are congruent because these lines are parallel and this transversal is cutting through them. And the transversal is a line as well. So again, this kind of falls into the, I don't want to say it like this, but into the no-duh category, where if I take angle F and I bring it up here, it has to be congruent to angle B. As you can see me bring it up, there's no other way for it not to be. It kind of has to be, and that's just one of those postulates, literally it is. It's something that you kind of have to accept to be true, accept to be fact. But using this postulate and the use of vertical angles, we will prove that alternate interior and exterior angles are congruent and that same side interior and exterior angles are supplementary. And all these statements will be biconditional. What does that mean? What that means is, look at this statement right here. If a transversal intersects two parallel lines, then their corresponding angles are congruent. It means that the opposite is also true. This is a one-to-one matching of fitting definitions. If a transversal cuts through two lines and their corresponding angles are congruent, then those lines are parallel. And that's what makes it a biconditional statement, that you could say it the other way and it's still exactly true. So all of these will also be biconditional. Okay, so we have a lot of stuff written on here. Let's kind of walk through it. First, we're going to look at alternate interior angles. Given the fact that lines L and M are parallel, we want to prove that angle F is congruent to angle C. And again, these are alternate interior angles. So before you had it stated to you, but let's prove it. So first, we're given that line L is parallel to line M. Given that fact, we can talk about the corresponding angles postulate and use one of these angles to help us out to begin with. Angle F is congruent to angle B, as you can see in, let's use blue. As you can see in blue, angle F is congruent to angle B by the corresponding angles postulate that you just saw on this last page. Whoops, on this last page right here. The corresponding angles must be congruent. F and B, as I said, are. Angle B is congruent to angle C. How come? Because vertical angles are congruent. If that's the case, then angle F must be congruent to angle C using the transitive property of congruence. So if F is congruent to B and B is congruent to C, then F is congruent to C. It's also, you could say substitution. Transitivity is a unique form of that. You could say either or and it's going to work there. So the theorem of that is, if a transversal intersects two parallel lines, then alternate interior angles are congruent. There's the proof, and that'll always be true for parallel lines and a transversal cut through them. So if this measure is 70, then this measure is also 70, because this measure is 70. All right, alternate exterior angles. Let's do the same thing. I'm going to write it pretty quickly. I want to save us some time. Given that L is parallel to M, prove that angle A is congruent to angle H, these alternate exterior angles. First, line L is parallel to line M given. Now what you want to do is make a statement. You could do corresponding angles, which is what I'm probably going to do here. But you want to use A or H to make it happen because these are the ones you want to prove. So I want to say angle A is congruent to angle E. Let's go ahead with that one. Those are a set of corresponding angles. I'll just say core angles. You understand that. It's going to be the same as this one, basically the same thing. Now, you've used angle E. Let's use it again. Angle E is congruent to angle H because those are vertical angles, and vertical angles are congruent. Therefore, if A is congruent to E and E is congruent to H, then A is congruent to H, once again by transitivity. The idea that you have substituted The E has kind of flown through this, and you can substitute A for E now that you've made that statement. So the theorem with that then, that's A and H, if a transversal intersects two parallel lines, then alternate exterior angles are also congruent. So there's your proof. Okay, so we're going to do this for same side interior angles and same side exterior angles as well, only this time it's not going to be that they're congruent, it's going to be that they're supplementary. By supplementary meaning adding to 180 degrees. Now this one's a little different because we haven't really looked at supplementary angles that aren't linear pairs, meaning right next to each other, this and this, right? Now we're going to be looking at angle E being supplementary to angle C. They are not congruent, not necessarily, not unless they were right angles, but these should be adding to 180. How? Let's see the proof. Line L is parallel to line M that's given. Angle E, now here's one of many ways you could do it. I'm just choosing one way here. Angle E is congruent to angle D. How can we say such a thing? How can we say those are congruent? Well, those are alternate interior angles. Now that you know that, you can use that. Right? We just proved it on the last slide, but now you can use it. Angle E is congruent to angle D. Angle D is supplementary to angle C, as you can tell here. Now, your reason, you could say something about linear pairs. We haven't really used the term, but adjacent angles that form a straight angle are supplementary. They both add to 180. So if angle E is congruent to angle D, and angle D is supplementary to angle C, then angle E must be supplementary to angle C. It takes place of D because they're congruent. That one's substitution. So if D is supplementary to C, E also must be supplementary to C. So the theorem, if a transversal intersects two parallel lines, then same side interior angles are supplementary. And lastly, we're going to do same side exterior angles. So given this, let's prove that angle B is supplementary to angle H. So same side, exterior, adding to 180. L is parallel to M given. Let's go ahead and do a corresponding angles. One, I missed that. Let's say angle B is congruent to angle F. Corresponding angles. So B and F are congruent. Look at F and H. They are linear pairs. So angle F is supplementary to angle H. Why? Those are those adjacent angles that are adding to become a straight angle. They're linear pairs. They are supplementary. If that's the case, then angle B, if you substitute, must also be supplementary. And as again, that's a case that was built up. Angle B and angle F are the same measure. Therefore, angle B plus angle H should also equal 180, just like angle F plus angle H. So if a transversal intersects two parallel lines, then same side exterior angles are also supplementary. And these are proofs. Like we've proved it. You cannot dispute it anymore. Only true for parallel lines, though. Okay, so now that we've had that all up, let's go ahead. I spelled relationships wrong. You can look at that. Let's go ahead and, all statements are biconditional. So if I just quickly go back to one of these, what if I said if a transversal cuts through two lines and same side exterior angles are supplementary, then those lines are parallel, right? That's the biconditional statement. You could go back and prove that the lines are parallel using kind of backwards approach here if this was given in the other way around. Anyway, so they're all biconditional. So adjacent angles, nothing too specific about them, since that they're always congruent or always supplementary, but they can form linear pairs, potentially, if they add to 180. Vertical angles are congruent. Corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. Same side interior angles are supplementary. And same side exterior angles are supplementary. Fiend.